For this exercise, we're going to make the robot to draw some letters. And I will use the letters A, B, C as an example. And you'll be provided with the data or the coordinates to create any character from A, B, C, D until Z, X, Y, Z, and even the umlaut characters Å, Ä, Ö in the Swedish alphabet. But anyway, the characters A or the character A here are the coordinates starting here. We draw from this position 0, 0. We have X in that direction, which resembles a table from the robot's stand position, so to say, and Y in this direction. And then we draw like that down here. We have to lift the pen and draw there from there to there. So these coordinates have to be representing robot targets to start up with, and then we continue from there. And just to have a glimpse about the other characters, like B is like this one. We start in this manner from here. This we can draw in one stroke without lifting the pen. In this way. Now we have curved here. The curve need a midpoint to be defined in the language of programming the ABB robot. So the curve starts here by a midpoint here and an endpoint here of that half circle. That will be explained later on. And for the C, it's a similar approach, but that is pretty much simpler in a way. It's just one arc, so to say, starting here and ending here. Okay, so we remember, or you have the data for the characters, the letters to be drawn. We start with the A character, and then we get that working in a proper way. So what we're going to do now is to define and actually modify the work object that defines how we work with the emotion, so to say. So if we open up the work object and targets and the front table, so we then can right click on the work object F table and click on modify work object. And in this set of data, we can see that the user frame already has the data defined for the table in a calibrated position. That's fine. That is actually this frame here, which is located on the surface of the table. And the Z is pointing down, Y in this direction, X in that direction. So that seems to be fine. And then we can say that we start drawing 50 millimeter inside the plate or the paper. So that's sort of a safe position in a way. And then we draw in the normal way from left to right. And so that will be fine. That will be the local origin, so to say. And to do that, we define the object frame position with some values. That will be 50 millimeter in XY direction, because we now work in the local new frame defined by the user frame data here, set here. And the Z should be then minus 12 millimeter, which will lift it up to the paper, so to say. Well, the paper is 0.1 millimeter in thickness, so that really doesn't matter. So 12 millimeter up, it's minus 12, accept. And then apply. So we get the starting frame here actually for any activities in drawing. Close this one. And the next thing is actually to get some robot targets defined. And what we're going to do is to make sure that we have the right work object here. We can set that already, where work object 0 is actually defining that everything is related to the base of the robot. That could work for the starting positions, but we work all the time relating to the front table. Define that. Tool is correct, that's fine. And in the bottom, when we define motions, target robot targets, we can define how we do this. So we try with move L as default. Alternatively, it could be move joint and so forth, but that could be fine. If we need to change that, we do that later on. Velocity from beginning is 1000. Could even be higher for the via motions, but when we draw, we go with a say 100 millimeter per second, so we get the drawing in a nice way, and we can see what is happening. The pen tool is fine as it is, and the work object front table. So everything is fine. We do this. Everything else we can add it later on. So that's fine. So what we're going to do is now just to get things working, and we do this like this, that we create the first robot target at the position which is the home position of the robot. Just click on that one, and that will appear if we open up the work object F table of target 1. That is that one. Fine. And then what we do is just to manipulate the robot, and click on layout, right click on the robot target, and then we can do like this, that we make a joint jog. Why I do this is that I would like to have a set of well, to get the robot in a position for drawing in the correct way. Let's put it like that. And that means that we want to lower the fifth axis so it points downwards. That it should be that one. We see in what direction it is. Okay, that one direction, and we see that, okay, it's approaching this here. That should be 90. Just click on 90 and enter the keyboard. It goes downwards like that. That is perfect. Pretty much, and we can close this now, and we do like this, that we can make a linear jog now, and we can move it in well, let's see how it moves. Like, oh sorry, it was pretty much correct. In the X direction is red, and the Y direction, now we have 10 millimeter per degrees, like that. So we start from that one, and we move it inwards to get a rough position to start with. Like that. Quite okay. That's fine. And then we'd make a teach target on that one as well. Close this one, and what we're going to do then is just to start drawing actually, but we could have another position just above the origin. So what we can do is to click on target here, create target, and the reference could be work object. Work object is the front table here, and position could be X, Y, and we say minus 25 millimeter, and we add that one, which will be just above the paper, and create that one. So now we have the home position, the via position and the approach. We can actually, well, we can keep it as it is. But if we would like to do that, okay, we can do that. We can rename those. So this could be the home position, like this one, and this could be just click one more softly. It will pop in the rename via pos, and that one could be the approach paper, for example. So we know what we are doing with these kind of and what we can do at this moment already is actually to open up the path and procedures. We have the main entry point that is always there, so to say. If we right click on this one now, we can create a path, and we can click on that once and it open up as changing the name, or right click on it and select rename the procedure, and that could be the approach path, something like this. And then we do like this, we to take all those and draw it, drag it down to that one, populate it, but now it is in the wrong order. So home pos draw that. Sorry, it doesn't work like that. We have to move it down this more. Move down like this one, and so home position, approach paper. Sorry, draw this like that. Home pos, via pos, and approach paper. So what we are going to do and what we can see now is actually that it really doesn't match very well, because the orientation is so different, as you see here. So we start with that one, move from that to that. Seems to be pretty straightforward, because the X direction is the red one, that is going to be that one, the Y is that one, going to be that one. But when we go to this rob target here, we are still with the same set orientation, but the Y changes from this to this. So that is not really good, I would say. So what we're going to do is to rotate this target 180 degrees. And so we're gonna do this here, and we just do like this, that we modify the target and rotate, and around Z and 180 degrees, apply like that. So this is pretty important, that orientations, specifically orientations, match what the robot is capable to do. It might have been possible to do this, but then to the cost of extensive rotations, which takes time, especially if we move fast, because this should be fast motions. So this should work pretty well. Now, if we have something like this, we click on the approach path, right click on this one, and we have an option to do auto configuration. That means that the robot checks and selects a configuration of the robot axis in a manner that matches the same for the whole path, if possible. Select all. So it will do that kind of path, and then we can move a long path as well. So it will simulate it, and it will make a rounded bend here in a way that makes it move fast. We will come back to that later on. Fine. So now we have that first all set. Okay. So the next, now we remember we have to rotate that 180 degrees. So the next thing is to define the proper targets for the letter A. So we create the target, and the reference should be the work object, which is this one with the origin here, with the user frame, and we can name the target naming policy here that this is a path, and we can start with 10. It will incrementally name it a path, or just a10, a20, a30, and so forth. And that is fine, and we define it according to the coordinates supplied for the letter A. That means we start with the 0, 0, 0 actually, because it is on the surface. And what we can do already now is we change all these to 100, and we change the set value, which is a zone, to calibrated corner points. We set that to well, we can change that later on. We set it to Z1 at the moment. That's fine. And then we start with adding points. That is the first one. And the second one is it stands at the X, so we just put in 50 on the keyboard, and the tab get us the next one, 20, and click on add. Oh, sorry, this was not meant to be. I click on that one and put on rotation 180 degrees, modify, and that one 180 degrees, modify, like that one. That should be fine. Okay, and then we go to, we have 50, 20, and then we have 0, 40, and we keep this 180. Add that, and then we have the stroke in the middle of the A, which is 20, tab 8, add, and 20 is the same, just click on tab, and then 32, add. So that should be all for the A character, and create like this. They are all with the right orientation. We take away that one, and then we create a path, which we just call, a path. Oh, sorry. Path A, like that one. And we take that one until that one, and just select in a normal way. Click on the first one, hold shift, and click on the A50. You will select all of those in the same way as you should normally do in the editor, and drag them down to path A. There should be no difference. And now when we have those, we right click on path A, and we make a auto configuration or instructions. It was done pretty fast, and then we move along the path. Seems to be fine. What we could do is actually set the TCP trace and see how things move, if possible, and move along the path. Well, it doesn't show so much anyway, because we don't have a program yet. Okay, never mind. After this, we go ahead and create the program and see how it works. Okay, so we go to the Home tab and make a synchronization to the Rapid. That will actually generate a code, but before that we make sure that we have something in the main entry point procedure. So we can do that manually in the editor, so that's not the problem itself. So it can be done either in the Rapid language editor or here. Some things are more appropriate in the other in one of the other ways, so to say, but this really doesn't matter. So we take the approach path, drag it to the main entry point, and we drag the path A to the main entry point. And if we open that one, we can see that we start with the approach path, then go to path A, and we can already at this stage define a retract path or go home great path. We can call it retract path. Actually, it can be named in any way, so that really doesn't matter. So what we do here is that we move to the approach paper position like that, and then we go to the via pos like that, and then we go to the home pos backwards in a way. So that shouldn't be any problem with that. No, works fine. And now when we have this, we do the synchronization to the Rapid, which is actually the controller module. Okay, click in everything, and then we created actually the program. Open up the Rapid tab until we see the main module and the module 1. Module 1 contains, double click on that one, contains what we just created. Also, the main module is the main module we created with a procedure main, approach path, path A, which kicks the ball rolling, so to say. We missed actually one thing. We missed the last part. That's strange, but we will fix that. Maybe we forgot about it. We'll fix it later on. Sorry about that, but that happened, so that's fine. I mean, that's not a problem. You will see that all the time. So what we have here, we have the approach path with the move L all the time. Actually, that is working here, so we don't change that. We have velocity 1000, Z100, which create these nice motions when we have corner points and so forth. We have the pen tool. So we skip the rest. We just see it home pos, via pos, approach paper, and then we move along this here. So that's not a problem at velocity 100, and with the zone set 1, and we have the retract path in the same manner, and that's pretty fine. And what we can do also is to open up the Rapid Path Editor, and that is pretty nice tool actually. We start here. And if we move to this one, we will see the A character. And if we change something, we change this, for example, that one here. If we change the Z1 to Z10, so we see what happens with the corner when you do this kind of interpolation. So before it approaches that position, it starts to bend over to the next one within a distance of approximately 10 millimeters. So it's pretty nice. It would also change the speed of operation. Okay, and what we do now is just to make sure that we can do a proper simulation. And we just make, and well, I just made a change, but it wasn't really a change, it changed back, but I had to do an apply all. You can see that there were no errors here. And what we do is that we add the retract path in the main module. Click on that one, and we add here retract you can see that you get it suggests something that it knows about. Click on that one, direct path. So that's fine. And now we do an apply all, and we see no errors. Everything is fine. And then we can do synchronize to the station. So we have everything in place as it should be. And if we go back to the home tab and into the main, you can see that we have all three here. That's fine. Then we can move to the simulation tab and we can actually play everything, and it should work in a pretty nice manner. Now I see they have the trace on, but I can hardly see what is done. So I open up that again and I change the color to something more visible, like dark blue or something like that. That will be fine. Play it again and we can see it actually what's happening. So what's done here now is that it moves down here, as you see here. Here now you can see there are small bendings here, and that is because we don't have a fine position. If we change that now, we can do that. Go to module 1, and the Z1 should be fine instead. So we do like this, that we finally replace Z1 comma to fine comma and replace all. That's fine. And then we change to output. We want to see what's happening so we don't do any mistakes. Apply all and no errors. Good. And synchronize to the station, and then simulate it. So that should be sharp corners in all those places. So that's fine. Now what is missing for the first character is actually that we don't raise the pen, but I will do that in the next video.